Okay, so I worked a little bit ahead. I want to talk to you about the x-intercept. The x-intercept comes from the top, and remember, we are going back to the current line of our work, which is this reduced equation right here. So for the x-intercept at the top, notice it's 3x plus 4, and remember it's understood to have a degree of 1 when it's not written. So here's our x-intercept from the top. If you're not sure how I got negative 4/3, then you set this top equal to 0 and solve for x. Now remember it has a degree of 1, just the top. So we know that behavior for this x-intercept is going to go straight through. Okay, y stands for the y-intercept. This is probably the easiest of them all, and most of the time we can do this in our heads. So remember, for the y-intercept, the x value is 0, and that's why it's going to be easy. When you plug in x's into the entire equation here, the top part, that 3x goes away. That's just going to leave a 4 on top. Down here, that x is going to go away. That just leaves a 2 underneath. So all we have to do is just divide these constants. 4 divided by 2 is going to be a positive 2. And now we are ready to graph. I like to save the domain until after I graph it because visually it's a little bit easier to see what the domain is. All right, here we go. Back to the top. I'm going to go in the same order I did to solve. So the first thing I'm going to do is I'm going to plot this hole, and it is a discontinuity, so notice I grabbed my red pen. So sketching this stuff, just make sure to remember it is a sketch. So -1, +1, that's going to be in quadrant 2. I'm just going to estimate -1, +1 to be right here. Now I'm not way concerned about these y values on the y-axis unless I'm plotting specific points like a hole. So I'm going to write -1 here. I'm going to write +1 right here, and I am certainly not going to color that in. Remember, that is a hole. I need to be able to see through it. While I have the lid off this pen, I'm going to go ahead and graph these vertical asymptotes and horizontal asymptotes. Remember, we had a vertical asymptote at -2. -2 came from just the denominator. It is going to be the opposite value. That was raised to the first degree. The first degree is odd, so my vertical asymptote is going to have opposite behavior. So if that's -1, I'm going to say -2 is right here. So a vertical asymptote, remember, is an attribute, but it's invisible. That's why you must make sure that this line is dotted. We always have to label the asymptote, and we always have to state its behavior. All right, one more asymptote, y equals a +3. So I'm going to say +3 looks to be around here. This is a horizontal asymptote, but y equals 3. And there's no like weird behavior or anything like that, so you'd never write opposite or same on a horizontal asymptote, just the y equals. All right, that is it for this asymptote and discontinuity stuff. So back to my other pen, my main graph pen. I'm going to go ahead and plot 0, 2. The y-intercept is for sure part of the graph. So y2 appears to be, or I'm sorry, 0, 2 appears to be right there. All right. And I kind of just glazed over that x-intercept. Oops, I should have did that first. That is at -4/3, 0. So -4/3 is just a little bit past -1, because that's like -1 whole and a third. So that's going to be -4/3. We're going to put right here. And remember, it is an x-intercept. I do need to color this in. Don't forget to always, always, always state that behavior. All right, we actually have a lot of graphs, or a lot of points right here. We can kind of visually see this branch. So what's going to happen is, remember, graphs love asymptotes. So I'm going to start down here because I can clearly see it's going to go through this point. It's going to hop over the hole and then continue to the other side. But what my main job is to try to get as close as possible to that asymptote without touching it. All right, so I went, connected, hopped over the hole, connected to the y-intercept. Now look, we're up here with a horizontal asymptote. that graph loves that horizontal asymptote too, so we want to get close to it. Now what do? Go back to your vertical asymptote and look at the note that you wrote yourself. You wrote to yourself that it was opposite behavior. You just drew a down arrow, so we have to draw the opposite. We have to draw an up arrow. But remember, graphs love asymptotes, so we're going to go to the top and draw an up arrow on the other side where we already drew the up arrow for this vertical asymptote. So we do have another little baby piece. We do not have any x-intercepts here, so all this little baby piece can do is just do what it does the best, which is hug asymptotes. And that is how you graph a rational expression or a rational equation. Let's go ahead and talk about the domain. See, it's kind of easy because we'll just scan using our eyeballs here. So the first thing I see over here on the left is an arrow. So when I see that arrow, of course, that's going to mean negative infinity. Now we're going to go to negative infinity and block out our first discontinuity, which is -2. We're going to pick right back up after -2. And remember, we skipped over this hole. This hole has the x-coordinate of -1, so let's exclude that. And then once we do that, we're scanning. The last thing I see is going to be a infinity symbol. It is getting closer and closer to +3, but my x values will go on forever. So after -1, that graph is going to go on for the domain forever.